We are back on the backhoe. Don't worry about that. We'll talk about that later. If you haven't seen part one, this is a 580C case backhoe, and it leaks pretty much everything from everywhere. I rebuilt 3 of the cylinders, replaced the hydraulic oil, changed a few of the other fluids, and then we found a major leak up in the front. It's hydraulic fluid. It's got to be coming from the hydraulic pump, which is direct driven off the front of the crankshaft. You can't even see it down in there. But according to the manual, it's not too bad to get it out of there. We got to pull the grill and that guard at the bottom, and then we should have pretty easy access. So I guess we'll find out if that's true. I've already drained the oil that I just put in, and I think we're ready to go. Yeah, okay. Hoping I can unhook this suction line, unbolt the pump, pull it out, and leave the pressure hoses still hooked up. We'll see if that works or not. Yeah, this is lovely. I just noticed this radiator has plastic tanks. That's got to be a replacement. There's no way it had those originally. Yeah, sure enough, it says 2001. Made in the UK. Yeah, there we go. I don't know, the manual shows 2 pump options, a Cessna and a TRW. And for my money, this pump doesn't look like either one. So maybe it's been replaced, or maybe it's just a little bit different model than what they show in the book. Don't know. I'm gonna try pulling this seal out. There we go. I don't know, it doesn't look that bad to me. It's kind of hard to believe it would be leaking that much. I don't know where else it could be coming from. Okay. Well, according to the manual, on the Cessna pump, the seal diameter is the same as the spline diameter. That's not the case here. So maybe this is a TRW pump, I don't know. I think that's pretty good. You ever wonder how the shaft seal on a hydraulic pump actually works? Yeah, I didn't think so, but it's pretty clever, so I'm going to tell you anyway. If you think about it, this pump can make 3,000 psi, about 20 bar. So how does a single lip seal hold back that kind of pressure? Well, the short answer is it doesn't, but the long answer is a little more complicated. So this is a gear pump. The input shaft is connected to a gear, which drives a second gear. And the gear teeth trap oil and carry it around the outside of the pump housing, both gears. When it gets to the outlet side, it can't go back between the gears because the teeth are tightly meshed. This is basically sealed. That creates a positive displacement, which we can use to make pressure. If you look at sort of a section view through the input shaft, this is the gear that does the pumping, and on either side is a thrust plate. Typically they're made from bronze or some kind of bearing material. You can see them here and here. This thrust plate is fixed. It fits right up against the body of the pump. This thrust plate is floating. It's basically like an oval-shaped piston, and it has this kind of complicated seal that seals it to the housing of the pump. And what we do is take the high pressure that's generated by the pump and feed it back to the outside of that thrust plate. And we use that pressure to push the thrust plate into the gear and squeeze the gear between the two thrust plates. And that creates a seal, a hydrostatic seal between the gear and the thrust plate. And the higher the pressure, the more it squeezes, the tighter it seals. Now, inevitably, some amount of oil is going to leak past that mechanical seal. So all we have to do is put a little channel in here to redirect that oil that leaks past back to the low pressure side. This is zero pressure. So the seal that we're replacing, it really just holds back the inlet side, the zero pressure side oil. The actual high pressure sealing is all done with a metal to metal seal. And there's orifices and check valves and different things to keep the pressures the way they want them to be, but that's the gist of it. It's pretty clever. Now, kind of the drawback with gear pumps is that they're not very efficient, but the upside is they're very cheap and they're very reliable. So they're essentially ubiquitous. And before I put the pump back on, I got to bar the engine over so that we can drain the fluid out of the torque converter. There we go. I swear to God, people here, they take their truck to the shop and they say, I want the loudest exhaust and the loudest tires you have. Don't care what it costs, don't care how long it lasts, just give me the loudest one you have. Anyway, anytime you got the pump off, you always want to check the fan belt because you can't replace the fan belt with the pump installed. This one's not too bad, but you know, there are hydraulic pumps that take a whole day to remove. So this fan belt has seen better days. It's supposed to look like this. So we're going to go ahead and replace that. I can't believe it was working at all. It's not too bad. You got to kind of fish it around the fan, but other than that, it's not a big deal. The service manual has a lengthy and I would say borderline insane procedure for lubricating the splines. You're supposed to use molybdenum grease applied with a brush, only brushed in a certain direction, only applying a certain amount. It's very detailed, extremely detailed, borderline insanely detailed. But these splines are pretty much worn out, so I don't think it really matters. In fact, the coupling actually has a grease zerk on it, so you can reapply grease to the spline. There we go. Now, something's been leaking a lot up here, and I don't think it's just the seal on the hydraulic pump. I'm pretty suspicious of these hoses that couple the suction line together. This one I know is wrong. That's just a piece of heater hose. It doesn't have any reinforcing in it. I don't think that's right. So we're gonna peel this thing apart, make some new hoses for it. Maybe. These things are old and really stiff. There we go. Boy, this is some nasty stuff to try and cut. So it's suction rated hose. It has a single wire that wraps all the way around it like a big spring. And when you cut it, that wire turns into a razor sharp hook that sticks out of the cut. That is super dangerous. I'm gonna have to cut that off with a wire cutter or something. We got the pump and plumbing installed, and I refilled the oil. It's been sitting for a couple of days, and there are still a few drips on the floor. I'm gonna hope that's residual oil. I don't think it's leaking. At least that's what I'm gonna tell myself. So I'm gonna go ahead and button that thing back up. I believe we're done up here. This machine actually has kind of two separate transmissions. So this guy right here, bolted to the back of the engine, is essentially like a regular automatic transmission that you would find in a car. There's a torque converter, and then there's a pair of clutches, one for forward and one for reverse. So it's like a one-speed automatic transmission. And then there's a drive shaft that connects to a 4-speed manual transmission. So you get 4 forward gears and 4 reverse gears. Pretty typical setup for backhoes and forklifts. There's a very specific procedure you're supposed to follow, and I'm going to follow it as closely as I can because I don't want to mess up the clutches. I've done that job once, I don't really want to do it again. So the first thing we're going to do is drain the torque converter. I had to bar the engine over, and there's actually a plug, drain plug on the bottom. Okay. Guess it holds more than I thought it did. And we'll go ahead and drain the oil out of this little sump. Oh, that wasn't tight. Of course it would go everywhere. Jeez. This machine is an absolute disaster for my floor. It leaks every fluid from every orifice. Alright, we gotta remove this little sump. Oh, maybe. There. Jeepers. Okay. Isn't there supposed to be a screen there? Look says there is. It would appear to be missing. This is the point in the project where all we can do is guess. That's the pickup screen, and it is missing the screen, the entire screen. And I can't find any remnant of it inside the transmission. So my guess is that at some point the screen was torn or damaged and someone took it apart and just completely removed the screen so the pieces of it didn't get caught in the transmission. Now you might be wondering why someone would do that, and we have a bit of a clue in the new one. So that's what it's supposed to look like. What do you think this thing costs? $50? $100? That little guy right there costs $327 at the local Case dealership. By the time I paid shipping and tax and bought a gasket, it was almost $400. And it doesn't even come with an O-ring. Yeah. Anyway, let's get that installed. Fun fact, you know what these 3 tabs are for? 1, 2, 3. That's how they held on to it when they were machining it. Used to do that all the time when I worked in the casting machining world. Of course, a lot of times the customer didn't want the tabs left on the part, so we'd have to cut them off. But it's the best way to hold on to something. 3 points makes a plane without trying to distort it. It's especially nice for parts like this where you can't clamp over the top because you have to machine the whole flange. The plug's back in the torque converter already. I think we're done on the bottom side. Let's fill it up. That's quite a complicated procedure. Filling the shuttle is pretty much like filling an automatic transmission. You're supposed to fill it up until you see it on the dipstick, and then you have to start the engine so that the pump can circulate the oil. And the pump fills the converter, and then you have to keep adding oil while it's running until the converter is full and all the pistons are full. Anyway, shouldn't be a big deal. One more thing. He wants to try and improve the controls for the front bucket. There is a slight amount of play in the forward and backward movement. Side to side, it's not as bad. So you push it forward to lower the bucket, you pull it back to raise the bucket, you go to the left to roll the bucket back, to the right to dump the bucket. And you can actually do kind of 2 things at the same time. But this deadband does make it a little tricky to control. This is the hydraulic valve, and this is the Rube Goldberg mechanism that controls it. It looks like everything's pretty much worn out. It'd probably be a good idea to try to tighten that up a little bit. Looks like the main culprit is right here in this linkage. Alright, so it turns out this thing is borderline impossible to get out because of this stupid linkage that goes down to the loader bucket. So I gotta have my assistant the screw right next to this vertical pipe.
Like that one?
No. There's a screwdriver laying on top of it. That one.
Are you
Go.
ready?
Yep. Stop! Okay, try again. I don't think it's coming out of there. Try it again. Keep going. Okay.
Yep, I got it.
Okay.
You know what this backhoe needs? A little bit more rust.
It's not that rusty. And I still can't move that thing out of there. There. Got it. Good Lord, why did they design that way? That is so dumb. Thanks for your help.
You're welcome.
I think my pressure washer is kaput. The pressure part works, but no burner for the hot water. If you got any hot ideas on what might be wrong with this burner, let me know. I can tell you that it's getting fuel, it's moving air, and the ignition transformer is working. Beyond that, I don't know. It worked fine the last time I used it. This time, it won't even try to light. This has been happening a lot over the last couple of years. The problem is, back when I was first setting up my shop, I had no money. Actually, thanks to student loans, I had less than no money. So I would buy old junk like this and fix it or rebuild it myself. The problem is, now it's been 10 or 15 years and all that stuff is completely worn out again. And a smarter person would have had a plan to replace that stuff as soon as possible, but I filed it under the temporary unless it works category and kind of forgot about it. This is an ancient, absolutely ancient Hotsy hot water pressure washer, and I bought it on an auction for $5 or $10, and I immediately learned a very valuable lesson, which is that there is no such thing as a cheap hot water pressure washer. As soon as I hooked it up, water just ran everywhere. And of course, the problem was they left water in it over the winter. That water froze and just broke everything. Split the heating coil and pretty much just destroyed the pump. So I replaced the pump. I replaced some of the controls. I think the pressure valve was also bad. And then I took the whole heating coil apart. I split the sheet metal, unwrapped it, took off the insulation, exposed the coil, and then welded it up. And that worked about as well as you might imagine. But I did eventually get it to seal up. And then I rewrapped it with new insulation, re-welded all this stuff back together. It's been fine for the last, 9 or 10 years. But it's probably time to send the old girl down the road. All right, back to work. I did get this gizmo pretty well cleaned up and disassembled. We've got a lot of problems, as you might imagine. Well, the big problems are right here. Those holes are all egged out, and then where this thing fits on the lever, that's pretty sloppy. And then the pins are just completely shot. This part here seems to still be pretty tight, so I'm not going to mess with that. I'm just going to focus on kind of the big problems. I think we're ready to put this thing back together, if I can remember how it goes. So I've got a bushing, 2 new links, a new pin, and then the new stub that we welded on to the end of the lever. That came out okay. All right. So like that. And then like that. So we'll stick our bushing on. Okay. Well, these snap rings are not exactly to spec because this is an odd, because the shaft diameter is just, you know, whatever I felt like making it. But I think it'll work. I mean, where can that possibly go? Pretty sure that's it. It is so much tighter now. It's not even funny. I gotta put a roll pin in this cross pin. Other than that, it's done. The mechanism has been reinstalled. I had to get some help from my lovely assistant who declined to appear on camera. I also gave him a shot of grease. There are actually 3 grease zerks for these controls, and I don't think they've been greased for a very, very long time because they really didn't want to take grease. What a difference. This thing's as tight as the day it rolled off the lot, maybe tighter. Actually, we figured out that it has a float position if you push the lever all the way forward, which you couldn't even get to before because it was so sloppy. Oh, it's a little stiff. Anyway, it's a massive improvement. You know those videos that are supposedly satisfying that I never understand? This is satisfying. Tightening up that sloppy old linkage. A lot of work, but you can't argue with the results. The bad news is it's still leaking. A lot. The big leaks at the back there, I think it's got a couple of bad hoses. That's not that big of a deal in the grand scheme of things. You can replace hoses. The loader valve leaking is kind of a bummer. There's not much we can do about that. There are no seals, as far as I know. It's just metal on metal, and something must be scored enough for it to leak. And yeah, unfortunately, there's not really anything we can do about that. The good news is it's out of my shop, and God help me, it is not coming back in. I've reached my limit. He can fix the hoses or he can get somebody else to do it. I don't want to do it. I'm done. My limit is 1 backhoe a year, and that limit is up. Thanks for watching. I had a lot of fun in my last video drilling out this tapered pin, and I got several questions about what kind of drill bits I use, which I never really thought about before, but I can certainly show you. You guys aren't going to like this, but my go-to daily driver drill bit set is this one I got from the Mac Tools guy about 20 years ago. At the time, they had a very generous warranty where they would pretty much replace any drill bit for any reason. But the joke was on me because our Mac guy went out of business pretty quickly after, so I never really got to use the warranty. About half the drill bits have been replaced, especially the small ones that like to break. But the secret to the longevity of this drill bit set is that I learned a valuable life skill a long time ago, which is how to hand sharpen drill bits. So a few of these still have the original factory grind, just kind of the weird sizes that I never use. But most of them have been hand sharpened many times, and they're quite a bit shorter than they started out. But my suggestion to you, if you're having a lot of problems drilling, learn how to sharpen drill bits. It is an absolutely essential life skill. And I've met a lot of other mechanics and even machinists who have no idea how to hand sharpen tools, and it's a major deficit for them. You know, they have to have a big stock of extra drills in case they dull one or break one. It's not an issue for me. If I've got a really nasty bolt, like in an exhaust manifold that I'm trying to get out and it's just chewing up all my drill bits, 2 minutes I can resharpen one with nothing but a bench grinder. Of course, I've got a lot of other drill bits. I've got left-handed drill bits. Sometimes those are handy. A viewer actually sent me these DeWalt drill bits that have the little pilot on the end. They're supposed to be a little bit more efficient. I don't know. But if I was in the market for a new set of drills, this is what I would buy, or something very similar. Don't remember exactly where I got these. Might have been from McMaster-Carr. These only come out for special occasions, but these are what they call mechanics length drill bits. So they're kind of a little bit shorter than a jobber drill, longer than a screw machine drill, and they have these flats, which your drill chuck can grab. That way you don't end up with the shanks all chewed up like mine are. This is a pretty typical US inch size set. It goes from 1/16 up to ½ inch in 1/64 increments. But there's actually a lot more drill sizes than that. This is a mostly full set of screw machine drills, which is kind of an antiquated term, but just means that they're a little bit shorter than regular drill bits. So I've got number size, fractional size, and letter size. But it gets better. So in this cabinet is kind of my stock. So these are all fractional drills, kind of left over from my production machining days. There are some carbide drills in here as well. That's a Goering, I believe. So I used to be a big precision twist guy. They were made not too far from me, I believe in Crystal Lake, Illinois. But then at some point they got greedy and moved all their production to Brazil. So I moved all my purchasing over to Chicago Latrobe. I like split point 135 degree drill bits. So these are number sizes, I believe, and maybe a few letters. And then this is a lot of metric stuff. Kind of just odds and ends that I've filled in over the years. These are Tidex, I believe, and those are coolant through carbide drills. These things are absolute animals. You can tell this cabinet used to belong to the state police. They kept all their cartridges in it. I got lots of taps. Those are metric taps, pipe taps. Those are US standard taps, I believe. Lots of end mills. These are center drills and countersinks and some slitting saws. You guys didn't know you're getting a full toolbox tour. So these are reamers specifically for dowel pins. So I've got a nominal, a press fit, and a slip fit for all the normal fractional sizes. And then down here is a bunch of larger drills and some reamers. There's an 1 1/8" reamer. Some other big ones. Just whatever I needed for the job. And then down here is all carbide inserts. Bottom drawer is empty, mostly. I shudder to think of the amount of money I spent filling that cabinet.